Welcome to the eLearnSecurity video training lesson on sqlmap. sqlmap is a tool that automates SQL injections detection and exploitation. In this video, we will cover its usage and some best practices to follow during a penetration test. As with every automatic tool, proper preliminary manual testing and right configuration tell a successful professional from an amateur. sqlmap is a command line utility, so to launch it, we need to open a terminal shell, type sqlmap, and then provide the options and commands we need it to run. Let's start with --help. The tool prints a long list of options and command switches. The fundamental ones are -u to tell sqlmap what is the target URL to test, --data to specify the content of an HTTP post request, and -p to tell the tool what is the vulnerable parameter of a request. If you need to get more information about what the tool can do, you can check the manual by opening the readme.pdf file. You can find it by opening the file manager at Places, Computer, File System, User, Share, sqlmap, doc, and then double-clicking on readme.pdf. This file contains extensive documentation on sqlmap and the techniques it can automate, and is a precious resource if you want to use the tool to its maximum. We suggest you reference it when you need to try sqlmap with new techniques. Before actually starting to use the tool, we need to know our target. So let us take a look at it by opening the browser and pointing it to http://sqlmap.test. Please note this is not a public website, but just an application running inside eLearnSecurity's labs. sqlmap.test hosts a site about mobile application technologies and a blog where registered users can comment to blog posts. There's also a search box in the upper right corner of the web application. For example, we can type in Android and click Search to search for blog posts containing the word Android. Let us try searching for the not exists string. As we expected, there are no articles containing that string. If you look at the address bar, you can tell that our search query is sent to the web application via the search get parameter. We can check if the parameter is vulnerable to a SQL injection by typing a string termination character and hitting enter. As you can see, the query no longer works, and the web application outputs an error, so this parameter seems to be vulnerable. To briefly test if this is a real SQL injection, we can test with the classic always true Boolean injection, followed by a SQL comment. Not exists, apostrophe, space, or space, 1 equals 1, semicolon, space, minus minus, space, minus. This time, we get all of the blog posts as output. Let us see what happens with an always false condition like 1 equals 2. We get no results back. These two tests confirm that search is vulnerable to a Boolean SQL injection. As you know from the training material, Boolean injections take a lot of requests to dump information. So let us try with a union-based injection. We clear the payload and try it with a new one. Not exists, apostrophe, space, union, space select, space, apostrophe, ELS1, apostrophe, semicolon, space, minus minus, space, minus. We get an error. This could be because of the different number of columns in the original and the injected query. We can add a field by appending comma, space, apostrophe, else 2, apostrophe, to the columns list. We get another error, so we keep incrementing the number of columns for the injected select. The application does not trigger any errors now, so we can tell that the query contains 4 fields. Moreover, we know that the search is vulnerable to union-based SQL injections, which are faster to exploit than Boolean-based ones. Let us switch to the terminal window to configure sqlmap in order to exploit this injection by typing sqlmap space -u, followed by the vulnerable URL. Then we tell the tool to test for injections on the search parameter by typing -p followed by search. Next, there is a very important step. We tell sqlmap which injection technique to use. Most of the time, sqlmap can figure the technique out by itself, but in many cases, that means performing a noisy and easy to detect testing phase. Moreover, some web applications could crash or become non-responsive. So it is better to directly configure sqlmap to use the best technique for every exploitation scenario. In our case, we type --technique = u, which tells the tool to perform a union-based injection. Now we can start it by hitting enter. sqlmap automatically detects the back-end database, so we can hit enter and perform tests just for MySQL. We can also let the tool perform all of the tests for MySQL by hitting enter again. After performing some tests, sqlmap confirms that search is vulnerable to union injections, so we can stop the testing here. As you can see, the tool detected the version of the web server, the web application technology in use, and the version of the DBMS to verify that we can grab the banner of the database by appending the --banner command to the command line. This time, we also want to see what payloads are used by sqlmap, so we also append -v3 to the command line and hit enter. This is the payload sqlmap used to extract the database banner. You can manually test it by copying it, pasting it as search parameter in the browser address bar, replacing the pound symbol with its URL encoded version, %23, and hitting enter. Being this is a union-based SQL injection, we can find the result on the output page. Let us switch back to sqlmap and start digging more into the application's back-end database. We can enumerate the DB users the application can see by issuing the --users command. There's only one user, blog. We can now check what databases are connected to the application by using --dbs. There are Information Schema, a default database in modern MySQL incarnations, and BlogDB. We copy the name of the BlogDB database, delete the --dbs command, and start enumerating the tables it contains by using -D, followed by the database name, and --tables. This lists the tables. To list the columns of the users table, you can specify it on the command line by deleting the --tables. Typing -T space users space --columns and hitting enter. We want to dump the username and password columns, so we delete --columns and type -C space username, comma, space, password space, --dump, and hit enter. sqlmap displays the results as a table. Let's test them. We can try to log in as admin by copying the password and using it to log in on the blog. As you can see, the credentials are correct. Please note that we used sqlmap to first find the data we wanted to dump, and then dumped it. Directly dumping the database content via SQL injections is not only very noisy, but it also could be too heavy for your client's infrastructure to process, especially on a large database. Get parameters are not the only way to perform a SQL injection. As you know, every user input must be tested during an engagement. For example, we can test the login form. The login form uses HTTP post messages, so we have to use an intercepting proxy to tamper with the data and test it. We start Burp Suite from the Kali menu. And configure the browser to use it by going to the menu, Preferences, the Advanced tab, Network, Settings, and setting it for every host and every protocol on 127.0.0.1, port 8080. We try to log in with some random chosen credentials. We use A and A in this example and click Login. Burp intercepts the request. Let us simply forward it by disabling the master interception and verify that these credentials are not valid. Let us re-enable Burp and try to log in again with the same credentials and intercept again the request with Burp Proxy. We need to test the login page multiple times, so we right-click on the request's body and click on Send to Repeater. If we switch to the Repeater tab, we can try to send the request as is and see how the web application behaves. The web application simply redirects us back to the login.php page. Let's try to inject something in the User Post parameter and click Go. User seems vulnerable. Let us see if Pass is too. Injecting into the Pass parameter does not make the application print errors. It behaves correctly. Pass seems to be immune from SQL injections. Let us try the user parameter in more detail. We try to inject a Boolean payload, A'' space, or space 1 equals 1, semicolon, space, minus, minus, space, minus. The application output changes. We have 3 new headers in the output: expires, cache control, and pragma. Let's try with a false payload. A'' space, or space, 1 equals 2, semicolon, space, minus, minus, space, minus. The output is different. We can verify that by using the Go Back and Go Forward buttons. Let us try with another always true condition. And another always false condition. User is indeed a valid injection point, so we can move to sqlmap and exploit this vulnerability. The initial command line will be sqlmap space -u http //sqlmap.test/login.php space -- data equals apostrophe user equals a ampersand pass equals a apostrophe space -p user space -- technique equals capital B space -- banner. This tells sqlmap to perform a post request to login.php by sending user and pass parameters as post body. It will try to inject SQL commands inside the user parameter, using a Boolean technique to retrieve the database banner. Let us hit enter and tell sqlmap to not follow the redirection by typing N and hitting enter. We want to skip the test for other database management systems and perform all the tests. sqlmap figures that user is vulnerable. We want to make sure that the login page uses the same database used by the search function. So, we enumerate the databases by using the --dbs command. and then we list all the tables. The database is the same, so we do not proceed more with the dumping phase. URLs, GET messages, POST messages, and headers can be very long to write on a command line, so we can directly export a request intercepted with burp proxy, save it to a file, and then use it with sqlmap. To do that, we switch to Burp Suite, go to the Proxy tab, right-click on the request body, and click on Copy to File. We now save the file in the root home directory and name it bloglogin.req. Switching back to the terminal window, we can use the saved request by typing sqlmap space -r space /root /bloglogin.req space p user space -- technique equals capital B space -- banner, and sqlmap will perform the very same operations it did before with a longer command line. If you noticed, the command execution was very fast. Let's check in detail what it's doing by using the -v3 switch. If you take a look at the debug information, the tool executed 0 queries. This is because the banner is information we already have. In fact, sqlmap saves information on the target, logs and extracted data to /user/share/ sqlmap/ output/ name of the tested site, sqlmap.test in this example. If you need to rerun a test or just want a fresh start, you can flush the session. We can do that by appending --flush -session to the command line and run the tool again. As you can see this time, sqlmap performed more than 100 queries to retrieve the banner. When performing tests during an engagement, try to stick to the methodology you saw today as much as you can. This will guarantee to you and to your client a well-done penetration test. And this concludes this video on sqlmap. Thanks very much for joining us.